Hi, welcome to our video for solving equations, specifically one-step equations. In math, we love to solve for some unknown number, which in this case we represent as x. X is just a variable. A variable means that it is able to vary, so the value of x could be anything. However, in math, sometimes we're given constraints to solve for specific problems. So for example, the way I could look at this is some number plus 3 equals 7. Now, in your mind, you can probably think, oh, x has to equal 4 because 4 plus 3 equals 7. However, if I didn't know how to solve for this problem, then I can use a method called undoing. And the whole idea behind undoing is to make a zero pair, and later we'll show you guys, or a giant 1 in order to eliminate things to get x by itself. So I want to get x alone. Right now, x is with plus 3. So I want to make this side add up to 0. So I'm just left with x, because x plus 0 is just x. So the opposite of adding 3 is subtracting 3. And because of this equal sign, I have to make it even on both sides. I'm going to minus 3 here. Whatever I do here, I got to do over here. And this, again, adds up to 0. So I'm left with x plus 0, which is just x, equals 7 minus 3 is 4. The nice thing about equations is that you can always plug your answer back in to double check yourself. So instead of x, I'm going to swap it out with 4 to check myself. 4 plus 3, does that equal 7? And yes, 4 plus 3 is 7, so 7 does equal 7, so that does work out.
All right, guys, we're going to try another example. So if we have an equation that looks like this. All right, so just as Tiana had talked about with the last equation that we solved, we want to get x by itself by making this part of our equation equal to 0. So because we have a minus 2 this time, instead of subtracting 2, because if we did negative 2 minus 2, that's not going to get us to 0. So to make 0 on this side, we need to add 2. So we have to do the opposite of whatever it says here. So if we add 2 on this side, this will make this be 0, and then we have to add 2 over here. So now we're left with x equals negative 4 plus 2, which would be negative 2. And if we check our answer, we can change x to be negative 2. So we'll have negative 2 minus 2 equals negative 4.
All right, so what if we have a problem that looks like this? It's not very noticeable, but there's no like plus or minus sign in between here, so I know I won't be able to undo with plus or subtraction. So whenever I have a constant and a variable right next to each other, that means multiplication. So there's like an imaginary little dot there to show that they are being multiplied. So this is actually 4 times x equals 12, or 4 times some number is 12. We don't know what x is, but we know it's being multiplied by 4. To undo a times 4, we're going to divide, because multiplication and division undo each other. When I divide by 4 on this side, I gotta do the same thing over here. Thanks, Emma. This doesn't make a 0, but this does make a 1, which still works in this case, because 4 divided by 4 is 1. 1 times x equals 12 divided by 4 is 3. And this is okay, because 1 times anything, that's the identity property, so we're just left with x equals 3. So, and again, you can always plug it back in to check. 4 times 3 is indeed 12, so we know that our equation worked out.
All right, guys, so we're going to try another one. So, like we just learned on the last example, there's no plus sign in here. It looks like there is a minus sign, but this right here is representing negative 3. And this is saying negative 3 times x. So, just like we talked about over here, plus undoes minus and multiplication undoes division. So if we have, and the other way around, division undoes multiplication. So if we have negative 3 times x, then we are going to divide by negative 3 to get this x by itself. So negative 3 divided by negative 3 doesn't give us 0, but it gives us 1, like Tiana talked about. 1 times x is just x. And then we have to divide this side by negative 3 as well. So 27 divided by negative 3 equals negative 9. So because 1 times x is just x, we have x equals negative 9. And then we can think negative 3 times negative 9, well, negative times a negative becomes a positive. So 3 times 9 equals 27.
All right, let's check out this last example here. This one's a bit challenging because a fraction means division, but this 2/3 is being multiplied with x. Again, we want to get x by itself, and it's being multiplied by 2/3. There's a couple of different methods, so we'll show you one way here. Because it's being multiplied with x, you can divide both sides by 2/3. When you're typing this in your calculator, though, that might be a little challenging, so you'll have to like group it. You'll have to do like 30 divide parentheses 2 divided by 3, so your calculator knows how it's being grouped. So that's one way you could solve it. You could also solve it this way, and you can use what we call the reciprocal of a fraction in order to make a giant 1. So to undo a times 2 on top, I have to divide by 2, and that will make a giant 1. This side is being also divided by 3, and because it's being divided by 3, I can multiply by 3, and that will also make a giant 1. 3 over 3 will also make 1, and then I'm left with just x. So the reciprocal of 2/3 is 3/2, and so when we multiply by 3/2 on this side, I can also multiply by 3/2 on this side. And again, this is our giant 1, 3 over 3, and 2 over 2, so I'm just left with x. So our 1 times x, which is just 1x, or x. When you're multiplying fractions, you can think of this as 30 over 1, because 30 divided by 1 is 30, and then you can just multiply across. So 30 times 3 is 90, and then 1 times 2 is 2, so 90 over 2, or 45. And again, you can plug in 45 back in, and do 2/3 times 45. Does that equal 30? And it does.